Trackside cabinets hold information about the track ahead, speed limits, gradients, distance between signals, even temporary restrictions. All this, together with the immediate state of the signals, is fed down to the track. Detectors under the train can then pick it all up by a totally electronic system from 2 wires between the track. A mini computer works it all out. All the driver's got to do is to read the computer's conclusion off a dial. It shows him how fast he's going, the maximum speed he may do, and warns him of future changes. Although the driver can see a green signal ahead, there's another at red, well out of sight. Although he can't see it, the machinery can. And now the target speed drops to 0. The stray green disc is a fault. He brakes as the signal gets nearer. His maximum allowed speed falls as the computer compares his distance from the signal with this train's braking abilities. If the driver chooses to ignore the computer and doesn't slow down enough so that his speed is above the safe maximum, then he's told off in no uncertain terms. If he persists, then the brakes are put on automatically. Even if the driver did nothing at all, then the train would still stop before the red signal. This is no longer an automatic warning system, but automatic train control. Now he must still obey the old established principle and observe Rule 55, but without moving from his comfortable seat.
This is the driver of the 1120 Bournemouth Central to Waterloo.
It's the same 2 wires between the tracks that are carrying his telephone conversation.
Wait for the aspect to change. Thank you very much.
That system has been designed not only to help the driver cope with a high density of trains, but also to cope with very high speed. These devices are for the future. For the moment, we are here. A 2,750 horsepower diesel brings an intercity into Bristol Temple Meads, a station that still retains some of Brunel's original structure. Tucked away round a corner is a very non-Brunel style building.
From Weston, leaving at 14:15 for Paddington.
In it is the latest version of everything that we've seen developing. These signalmen control 117 miles of track from Bath to Weston-super-Mare and beyond. For Temple Mead Station alone, there used to be 2 complete boxes, 700 levers and several men. Now it's these 35 switches within the reach of 1 man. You set the 21 points for a train to pass through these 2.5 miles of track like this. As miles away the points electrically click over, the route lights turn to yellow. When the train arrives, they'll change to red. It looks like an eccentric millionaire's train set. It's not. That flick of the lights represents several thousand horsepower and a train full of people. The equipment is modern. The principles are embedded in history. A magnetic version of the collar invented in 1890 and missing at Quintin's Hill protects a blocked line. The signalmen constantly take calls under the 80-year-old Rule 55. The interlocking between signals and points that came in after the Bowness accident in 1874 is no longer in a cobwebby cast-iron frame room, but in a temperature-controlled, fluorescently lit switch room filled with banks and banks of electric relays.
This sort of signal box is a long way from the red and white flags of the old Brighton line or the Clayton Tunnel disaster. For the moment, this is the end product of a struggle for safety that's been going on for 150 years. But it isn't the final solution. As train speeds rise to 125 miles an hour and then 150 miles an hour that British Rail are aiming at, presumably rare accidents will go on happening. And then the system will change again and move even closer to total infallibility. Nowadays, in a place like this, They reckon to work to an accuracy of 1 in 10 million. 1 in a million, for them, is 10 times too dangerous. And remember, you're about 200 times safer in a train than you are in your car.